check.
Our charger that is not here, at what point will you switch over?
Now the inverter is stable. Maybe we can switch now.
You switch over before you continue.
Now that the inverter is stable. Technical, come.
Okay, thank you very much. So see you by 3 p.m. Thank you.
Come now.
I'm going. Yes, I'll come back by 3 for my presentation.
Help me so that we would save power on this
Okay,
thing.
our brain is 12 to 1
Move
p.m.
this things to that side.
We are learning from now till 12. 10:30, 11:30, 1 hour 30 minutes.
Take, not the extension. This is the extension. Lock the extension on the wall there.
Won't you shock me and I'll die?
That's why you are technical. Plug it. Turn off the socket.
Okay, someone is asking, should we continue it every Wednesday from now on? Indicate. No, let's take a vote. Combining all our classes to Wednesday. Indicate. Maintaining our, please bring down your hands. Bring down your hands.
Turn it on now.
That don't come up.
Ah. Does it have a remote? Does it have a remote? Does it have a remote? You stand up now. Press the power button.
You will clean it this time around. I'm not fine.
It's on. Just press the power button. You're delaying the class.
Tell him that he will clean it. Just tell him he will clean it.
Well, please clean it for us.
Exactly. Clean it. That's just an easy step. As you step for you, clean it.
Wait. If you press it again, what happened? It's off.
Does it make it not because
Okay. Before we begin, I just want to ask, who knows what an IP address is? If you know what an IP address is, just raise your hand, let me see. Group 1, quiet. If you know what an IP address is, can you raise your hand? None of us here know what an IP address is. IP address, an IP address. Have you seen it before? All right. Where's the mic? Where's the mic? But do you know? Speak up then. Okay. The meaning of IP is what? Internet protocol. Okay. Give me the mic. Who again? All right.
It's a specific computer network that allows people to send and receive information.
No, I'm asking an IP address.
Yeah, an IP address is a computer network that allows people to receive and send information.
All right. Anyone from group 2?
An IP address is like a unique identifier on the internet that identifies.
It's okay. It's okay. You've said the right keyword there. The keyword there is what? He said something that made me interrupt him. What did he say? Unique what? Identifier. The main purpose of an IP address is to uniquely identify each device in the network. Do you understand that? Are we following? Unique. As you get admitted into Uniport, what does Uniport allocate to you? A MAT number, isn't it? Have you seen anyone that has a duplicate MAT number? So that means the MAT number is what? Unique, isn't it? So in the network also, we expect each device in the network to have what? A unique address. Do we follow? And that address is what we call the what? The IP address. All right. So, going with the slide, what's the topic now? Network what? Identification. All right. So we say the network identification is the process of assigning unique identifiers to devices within what? A network. Are we following? Should I take that again?
Yes, sir.
It's the process of assigning unique identifiers to devices within what? A network. We just wrote an exam this morning, isn't it? Or a test, right? Isn't it? And before we could access the server that was hosting that exam, what did we do first? We have to connect to the what? To the network. Are we following? And in the process of connecting to that network, there is a server also that is responsible for assigning what? A unique identifier to our phones, isn't it? Isn't it? All right. So the next point then, this can be in form of an IP address. That's the unique identifier we're talking about. It can be an IP address. It can be a MAC address. And it can also be what? Usernames. Now I've seen another one, MAC, MAC address. What's the meaning there? All right. MAC address, MAC means Media Access Control. It refers to the unique hardware. We've seen IMEI before. Have you heard of that word before? IMEI. IMEI. Okay, that was too complex. Serial number. Whenever you buy a device, it comes with a serial number, isn't it? Aha. whenever you buy a network device, it's going to come with a what? A MAC address. Are we following? That MAC address is what? The serial number of that device, which is what? The hardware address, isn't it? The hardware itself, that's the serial number. We call it what? What do we call it? MAC address. Are we following? So in the network, when you're in the network, you'll be assigned what? An IP address, isn't it? Because that device you're using to access the network is a networking device, it will also have a what? A MAC address. Are we following? So that means in the network, there is two addresses. What and what? Group 1, what and what? All right. Next one. Why is it crucial for us to identify the devices in the network? Can someone answer that? Why is it crucial for us to identify devices in the network? No, you've answered before. I want fresh brains. Fresh brains. Group 1. Why is it crucial for us to identify devices in the network? Someone from group 1. Should I give you? The question again. Why is it crucial to identify devices in the network? Group 1. Someone should deliver you now. Nobody? Huh? Take the mic, don't worry.
I believe it is crucial to identify devices within the network so as to share resources. In sharing resources, to identify what devices you're actually sending your resources to.
Correct. Clap for him again. All right. He did well. As you admitted into the university, you're being assigned a math number, isn't it? Now, when your lecturers grade you, what happens? They assign those scores to who? To your math number, isn't it? So that's why Senate building can know that math number from cybersecurity department ending with 101 is a first class student, isn't it? Because who said no? All right. So that identification is important so that we'll know who is making use of what? The resource in the network. Do we understand that? So it's crucial. 1 is to enable communication between the devices. 2 is to support resource allocation. And 3 is to support network what? Security. If the network was unsecure and you're putting in your card details, what will happen? If you're using an unsecure network and you're putting in your card details, I mean your debit card, what do you think will happen? This is a cybersecurity class.
Your important information are exposed.
Yes. The key word there is what? You are what? Exposed. Are we following? So that means anybody that is interested in looking into what is happening in the network can see your details. Are we following? So when we're talking about identification, supporting network security. So when you join the network and you're being assign an IP address, we can identify you, isn't it? Now that identification can be used to what? Safeguard what you're doing on the network. Are we following? So we can set up firewall rules that will not allow you to browse in an insecure way, isn't it? So that the network engineers save you from cyber attacks. All right. We'll go into the next slide. What's the topic here? What's IP? What's IP? I want to ask. We have two types of IP address. I've not gotten to that slide. We have two types of IP. Who can mention them? I need fresh brains. Huh? Okay, that's allocation. I'm not yet in allocation. I'm talking about the types of an IP. All right? You have an idea. Let me rephrase the question. We have two versions of IP.
IPv4 and IPv6.
Okay. Who knows why we have two versions of IP? If you know why we have two versions of IP, let me see your hand. Okay? All right. Take it. You raised your hand now.
One is the public and one is the private.
No. We're not there.
What's the question?
Two versions of IP. And it has been listed, isn't it? Which is what? IPv4 and IPv6, group 5. Are we in this class?
Group 5.
We have two versions of IP, which are what? IPv4 and IPv6. Now, I said there was a reason that brought IPv6. I'm asking, who knows that reason? The reason was that the IP address, the IP pool that was available in IPv4 was totally used up. Are we following? The pool, you have a pool from 1 to 100, from 1 to 100, and you come to the class, and you have 200 students that want to share from that pool. Would that pool be enough? Will it? All right. So that calls for exhaustion of the pool, isn't it? So we now have to create another new version, isn't it? So IPv4, the pool that was assigned for IPv4, is what? Exhausted. Are we following? Are we following? Yes. Do you understand the reason now? Yes. All right. So let's continue. In this part of the class, we'll be looking at the overview of IP addressing, how we address an IP address. We'll look at how to convert from the decimal numbers of IPs to the binary. Are we following? And we'll also look at subnetting an IP address. Subnetting. I've said another new word here. Subnetting. The full word is what? Subnetwork. Are we following? And what's the meaning of subnet? Anyone? The meaning of subnet? Subnet. When we talk about subnet in networking, what are we referring to? What's sub? Substitute, isn't it? You have an idea?
I think it identifies the number of bits.
Okay. Okay. Subnet is the division of a big network into logical, smaller networks. Are we following? We have a big network. We have a network for University of Port Harcourt. Now we need to divide that network to fit the different faculties in University of Port Harcourt. Are we following? What do? We subnet it. Does it make sense? Group 5, does it make sense? We have a big network. Are you following? You understand that? We have a big network. And we want to divide that big network to fit smaller networks. So what do? We subnet the big network. Are you following? It's the process of dividing a big network into logical subnets. So let me continue with the slide. Most of the devices on the internet communicate to each other using the protocol called IP, which you already know, isn't it? We know that, right? Okay. And most of the internet is running under version 4 of the IP protocol. Every device on the internet has to be identified uniquely, isn't it? Okay. This is done by assigning each device an address, which is going to be an IP address, isn't it? Okay. This IP address is called the IPv4 address or an IP address. It's just a matter of saying, okay, if you're using the version 4 standard, you call it IPv4 address. If you're using the version 6 standard, we call it what? IPv6 address. Are we following? All right. Now, next one is that an IPv4 address is a 32-bit number. Who don't know what bit means in this class? If you don't know what bit, B-I-T means, bit, you don't know what it means. Do you know what byte means? B-Y-T-E. Do you know what byte means? You buy 1 gig from MTN. What's the meaning of the gig? Giga what? Byte. All right? What if I say gigabit? I want to convert 1 gigabyte to 1 gigabit to a gigabit. What's it going to be? It's part of this slide, how we convert from this to that. So to convert a byte to a bit, you multiply the bit by what? 8. Are we there? So if I have 1 byte, that means I have what in bit? 8 bits. Are we following? So that means if I have 1 gigabyte, that means I have what? 8 gigabits. Are we following? So now I'm saying an IP address is equivalent to what? A 32-bit number. Do we get that? Do we get that? An IP address is equivalent to what? A 32-bit number. So what would that number be in bytes? What would that number be in bytes? If you're for 8, raise your hand. 2 persons for 8. Okay? Which other number? 4. If you're for 4, raise your hand. Alright, the 4 has it. So let's check it. 4 times 8, isn't it? Is what? So that's the correct one. Are we following? So that means that 32-bit number is actually what? A 4-byte number. Are we following? Now, let me bring us back to our department. Everything we're going to do in the network has to do with a what? A computer, isn't it? It's either a smartphone, a printer, or a PC, a laptop. All of them are what? Computers, isn't it? And from what you have known from computers, how do computers work? They must convert everything back to what? To zeros and one, which is actually what? Binary. Are you following? The computers work with what? Zeros and what? One. You type 10 as a number. Computer has to first of all convert it to what? Binary before it makes any calculations on that number. Are we following? Isn't it? Isn't it? Group 5, isn't it? Okay. So that means if we need to understand the theory of IP address, we must also know how to convert that number to what? To what? Someone said it to what? Correct. So first of all, let's look at it. Say an IP address, we reduce it to how many number in bytes? 4 bytes, right? Now, that means I can say each of these octets here is a what? A byte. Here, can we see it? 4 different numbers, isn't it? Separated by what? A dot, right? The first byte, isn't it? The second byte, 87. Are we following? Then what? 20 for the third byte, and 5 for the what? Last byte. Are we there? And I said a byte is equivalent to what? 8 bits, isn't it? So that means if we drop that number from 199, we're going to have 8 bits of numbers, isn't it? Isn't it? 8 bits of numbers if we drop the 199. So that means we know how to calculate to convert from the decimal number, which the IP address is currently written on, which is the 199, to convert it down to what? The binary. So I want you to just note this. To identify an IP address, that IP address, if it's in version 4, it must be in this sequence of what? 4 different numbers, separated by what? A what? A dot. Do you understand? 4 different numbers, separated by what? Do you have marker? In the class here, do you have marker? I don't know if this one. So I have something that looks like this. Did you see that? 4 spaces separated by what? A dot. Did you get that? And the next point in identification of an IP address, here we're talking about IPv4, is that that number must be between 0 and what? 255. We are not in binary, so not 1. We are still in decimal. Hold on. Do you follow? Is it easy now? To identify an IP address, to make sure that a number you have is an IP address. That number must have 4 what? 4 octets, or 4 different spaces, separated by what? A dot, right? And each of that space should contain a number between 0 and what? 200 and what? All right. So group 1, give me an IP address. Group 1, give me an IP address. Give me one valid IP address. 126 dot
56.
Okay, 0.56
dot 47
dot 19. Is that correct? Class, is that correct? Is that correct? Group 2. Group 2, someone to speak up. A valid IP address. Yeah? Where's the mic? Group 3, prepare. All right, take. Who?
192.
All right.
168.
All right.
23.
All right.
73.
Dot 73. Is that correct? Yes. Is that correct? Yes. He said 192.168.23.73. Is that correct? Yes. All right. Group 3. Group 3, who? Okay.
192.
Okay.
168.
Okay.
1.
Okay. So 1.0. All right. That's correct, isn't it? He said 192.168.1.0. Does it fulfill those two rules? Yes. Does it? Group 4, give me yours.
192.168.25.45.
25 the what? Okay. That's correct. All right, take.
192.168.1.1.
All right. Where are you going to? All right. Now the next one. Group 1, give me an invalid IP address. Give me an invalid IP address. Give me.
354.
354 dot
286.
dot 286 dot
149.
the 149 dot
419.
group 2. Take, give me. Take now, take the mic. Take the mic, you know. Speak up. An invalid IP address. Group 2. He doesn't know. You people should assist him.
400.
Yeah?
400.
400 dot
359.
dot 359
275.
dot 275
3.
dot 3. Okay? Take. An invalid IP address.
Three
300. All right. Group 4. Take. Take. You're pressing 4 in my class. You don't know. I can send you out though.
852.601.27.4.
What's the first word you said?
852.
852. All right. Shaman. 300. Okay. So all of us have spoken, all right? Isn't it? Yes, sir. A valid IP address contains how many octets? 4 octets, with numbers ranging between 0 to what? To 255. All right. So that means if I show you an IP address, you can either tell me if that IP address is valid or what? Okay. Question? I ask. Who wants to ask?
This is my question. How do you differentiate an IP address of version V4 and version V6?
Okay. Have I taught V6 here? Have I taught IPv6 here? Okay. We're learning IPv4 in the class here. You say IPv4 is how many bit number? You've seen it now. It's 32-bit number, right? Having 4 octets that ranges between 0 to 255. Can you identify any number that is a valid IP address, IPv4? You that asked the question, I'm looking at you. Can you? So if I show you a number now, if I call a number for you now, can you tell me if that's a valid IP address or not? Okay. I'm calling the IP address of 10.255.256.1. Is that correct? 10.255.256.1. Is that correct?
Not correct.
It's not correct. Why is it not correct? All right.
Is it correct?
Is it correct? Someone is asking, is that correct? 10.255.256.1. Is that a valid IP address? If you are for yes, raise your hand. 10.255.256.1. Is that a valid IP address? Is that a valid IP address? Okay. Why is it invalid? The presence of what? 256. Okay, that's correct. So, the difference between version 4 and version 6 is that IPv6 address is a 128-bit number. IPv6 is what? 128-bit what? Number. If you divide 128 by 8, what do you get? We're converting that 128-bit number to what? A byte. How many bytes do we get? 64. 16. A 16-byte number, isn't it? So that means we can divide 16. If we divide 16 by 4, how many do we get again? 4. So we can have 4 different bits. 4, 4, 4, 4. Isn't it? Making what? 16. And each of those numbers contains an 8-bit number, which is going to be 8 times what? 4. So in writing down an IPv4 address, it's going to look like this. Sorry, IPv6, thank you. It's going to look like this. Do we get that? Do we get that? Is there any difference between this and what I did before? Okay, so in IPv6, we do no longer make use of this. We now write them out as we use a column to separate them. No longer what? A dot. And an IPv6 number is not going to be a decimal number. All these numbers we called for the IPv4 address, they're decimal number, isn't it? Ranging from 0 to what? 9, isn't it? So an IPv6 is going to be in base 16. Are you there? Where does base 16 stop? 0 to 15. But we don't write 15 in base 16. So what do we write? Huh? E. Is that correct? After 9 is what? A, which is 10, isn't it? Followed by 11, which is what? Followed by 12, which is what? C. Followed by 13, which is what? Followed by 14, which is what? E, isn't it? Followed by 15, which is what? F. So now you can get a number or an IP address that looks like A, E, 1, 2, double colon. Are we following? So you go up, read up what IPv6 is. We're not treating IPv6 in this class. We're treating IPv4. Do you understand? You need to be grounded in IPv4 to understand IPv6. So can we continue? Okay. So we already know that the IP address has how many octets? 4 octets. All right, and the total size of an IP address is equivalent to what? 32 bits. All right. Our next slide here talks about how we convert from the decimal IPv4 address to the binary IPv4 address, which is what the computer sees. Are we there? Do you understand? This is now what? Number-based conversion. We're going to convert from base 10 to base what? 2. Do you know how to do that? Do you know how to do that? Okay, if you don't know how to do that, and you also know how to do that, just listen up. We have a shortcut in doing it for IP address. You don't need to go through the long method of mathematics to get it. You only need to cram or understand what that table is saying. Are you seeing that table there? Are you seeing the table? This is the table here, this one. Can we see it? Can we see it? All right. Do you remember 100, tens, and unit? I'm moved to insult you if you don't know it. 100, tens, and unit. Do you know? All right. In IP address, when you're converting from the decimal number to the binary, we have a table that is similar to that. But instead of HTU now, we have numbers instead. The first number is what? 1, which is like where the unit is, isn't it? Followed by what? 2. So if you notice, there's a pattern here. What's the pattern? You double the number. In mathematics, you multiply by what? 10. From unit to 10 is times 10, isn't it? From 10 to 100 is also times what? 10, isn't it? That's the pattern there, isn't it? Here, what's the pattern here? You double it. Times 2, all right. So 1 times 1 times 2 gives you what? 2, which is the next one, right? Followed by 2 times what? 2. Followed by 4 times 4. 4 times 2. Double that again. Multiply 16 by 2. Multiply by 2 again. Multiply by 2 again. At the end of the day, you should have 8 columns, right? Column 1, column 2, column 3, column 4, column 5, column 6, 7, and what? Is that the 8-bit number you're talking about? Can we see it? Remember, we divided the 32-bit number into how many bytes? 4 bytes, first of all. We divided into what? It was 32-bit number, right? We divided into what? 4 bytes. Now that 4 bytes, we say each byte is equivalent to what? How many bits? 8 bits, isn't it? That is, each of the octets has how many bits inside it? 8 bits inside it. And now I've just drawn a table that contains what? 8-bit number. Do we follow? So now, to convert any IP address, can someone give me a valid IPv4 address? All right? Take. You know it now. You don't know what an IP address is? Take, helper. Speak to the mic. I can hear you. 199. All right. Are we following? Are we following? She said the IP address is what? 199 the what? The 108.82 the what? 33. Is that a valid IP address? Is that? Okay, so let's convert that number from the decimal, which is it, to what? To the binary. Are we following? So the first one, what's the first number there? 199. Do you have, can we subtract 128 from 199? Can we? Yes. So if you can subtract 88 from 199, we're going to write a 1 in that bit. Are we following? I can subtract 88 from 199, so I put a 1 there. Do you understand? 199 minus 128. Do you get a number that is greater than 0? Yes. So that means it can go. So you write a what? A 1. I did the subtraction. How many are you left with? 70, 71. Please make sure what you give me is correct, though, because I'm working with you. 70 what? 1. All right. The next number there is what? 64. Can we subtract 64 from 71? Can we? Yes. So that means we'll have another 1 again. Okay? So do the subtraction. We're left with what? 7. Can we subtract 7 from 32? So we'll put a what? A 0. All right? Can we subtract 7 from 16? You put another 0. My marker is done. Can we subtract 7 from 8? No. Sorry, can we subtract 8 from 7? Thank you. Thank you, I appreciate it. Okay, I have 0 here, 0 here is for 16. Okay, so we cannot subtract 8 from 7, right? So that is another 0. So the next one is 4. Can we subtract 4 from 7? Okay, so we have 1. So do the, how many are left with? 3. Can we subtract 2 from 3? That's a 1. Then we have the last one. If we subtract 2 from 3, how many are we left with? 1. So the last one, can we subtract 1 from 1? Yes. At the end of the day, we have a number that is equivalent to 11000111 base what? 2. Did you subtract 1 from 1? You subtracted 1 from 1, isn't it? You put a 1 there. Which digit were we converting, first of all? 199 in base what? 10, isn't it? So you get now? Okay, let me go over it again. The IP address that we want to convert to base 2 is what? 199.108.82.33. Are we following? So now we've picked out the first octet, 199, and we want to convert it. Now it's to fit that number into our table, isn't it? And the highest number in the table is what? 128. Now the question is, can we subtract 128 from 199? Can we? If you can, if it is yes, put a 1 in that column where you have 128. 199 minus 128. What's the answer? 199 minus 128. What's the number? Is that number greater than 0? Is it greater than or equal to 0? So that means you can do it, isn't it? Aha. Do you understand now? Who can explain it, please? If you understood what we did, can you explain it? All right. Come on, explain it to him. Explain it so that you understand. Hey. Question. Question.
If 158, if the 158 is the portion that's equal to 151, you have 109 OAGs there. You have 109 OAGs. From that 109 OAGs, can you remove 128 OAGs and the remainder will be equal to or greater than 0? Sorry, take it back. I did not want again. If you have 109 OAGs, if you have 109 OAGs, is it possible that you can do 128 OAGs from 199 OAGs and the remaining one will be greater than or equal to 0? It's not possible.
It is now.
You have 1,000 naira. You go to Mama Abuja and she said her plate of soup is 500 naira. If you give her 1,000 naira, will she give you a change? Same thing. You have a number, 199. The cost of that number, where you want to put in that number, is 128. Will you have a change from 199? You put a 1 there and subtract the number. Where is the 128 coming from? He was sleeping, right? Can I carry on? I believe we understand it now. Okay, so let's do for the next number. The next number is 108. If you don't understand it, we're going to do this thing 4 times. So I believe by the 4th one, you should understand it. 108. Let's go again. Can we subtract 128 from 108? No, right? So that means the first number is going to be what? A 0. All right. 108 base 10 to base 2. The first number is what? A 0. Okay. The next number, 64. Can we subtract 64 from 108? Yes. True. We can. So we put a what? A 1. Now we'll do the subtraction. 108 minus 64. 44. So the remainder is 44. Can we subtract 32 from 44? Yes. So we'll put a what? A 1. Okay, do it. 32 minus 44. 44 minus 32, sorry, is what? 12. All right, before I write down the next one, we have 3 numbers, so that's 1, 2, 8, 64, and 32. And we left it what? 12, isn't it? So the next one is, can we subtract 16 from 12? The guy that was asking how we go 128 is looking down. We cannot subtract 16 from 12, isn't it? So we'll put a what? A 0. Alright? Next one is what? 8. Can we subtract 8 from 12? Isn't it? So that's a yes, which is a 1. What's the remainder? 4. Okay. The next one is what? 4. Can we subtract 4 from 4? We're left with what? 0. So I'll put a 1 there first for the 4. So our remainder is 0, isn't it? Can we subtract 2 from 0 and we'll have a number that is greater than or equal to 0? No. So we'll put a 0 there. What about 1 for column 1? No. At the end of the day, you have a number that looks like this: 0, 1, 1, 0, 1, 1, 0, 0. Does it make sense? Does it make sense? Let's go for the next one. The next one is what? 82. Already, 128 is greater than 82, so that's a what? A 0. Okay? We have 64. So 64 minus 82 is what? 18. 19. 18. Okay, so that's a 1. We are left with 18. 32, you cannot fit into there, right? So 0. 16. 18 minus 16. We are left with 2. So that's a 1 there. For the column 8 is what? 0, right? For the column 4. What about for the column 2? 2 minus 2, which is our remainder. Alright, so that we'll have a 1 there. And the last one is what? 0. 88. 82 base 10 to what? Base 2. Alright, the last one is 33. 33 base 10 to base 2. Can 33 fit into 128? Anyone? 0. What about 64? Another 0. What about 32? 1. Alright? What's our reminder? Our remainder there is what? 1. We started with 33 now. 33 minus 32. What's the remainder? 1. So we cannot subtract 8, we cannot subtract 4, we cannot subtract 2. We can only subtract what? 1. So I'll write it. 0, that's for 16, isn't it? Another 0 for column 8. Another 0 for column 4. Another 0 for column 2, and 1 for column 1. Is it simple? It's simple now, right? All right, ask.
It's actually very simple. I don't understand why didn't you start from 128 when we were dividing the next one, that's the 33. Why did
Okay,
you start from 128?
I actually started from there.
So why didn't you
From the Mama Abuja explanation again. I went to Mama Abuja and she said 1 plate of soup is 128 naira. Do you understand? And I have 33 naira with me. Can I buy that plate of soup? No. So that was why we put a 0 there. See, we got to the column that we could pay for. Do you understand? All right. So you see how that table was populated. Do you understand the way this table now was populated? Huh? Yes. Touch him. Touch him. Do you understand the way this table was populated? Yes. Okay. When you read through your slide, you get to know these other ones. This is another example. The IP address here is 182.92.199.27. Can we see the way the number was fit into that table? For 182, there's a 1 there. For 128 column. And a 0 for the 64 column. A 0 for 32. So you get to the end. All right, let's do something in reverse. We have a number. We have an IP address in binary. For instance, we have 11101101 in base what? 2. I want to convert it to base 10. What do you think we should do? It's simple. You plug that number into your what? Your table. Are we following? Listen up. You want to convert from the binary to what? The decimal. And you've got the binary number. You plug that number into your what? Your table. Now if I plug the number on the board there, we have 1, 1, 1, 0, and what? And 1, 1, 0, 1. So the leftmost bit, when I say that, leftmost, which side is the leftmost? This one here, right? The leftmost bit has a value of what? 128, isn't it? From our table, isn't it? So that means if 128 is on or off, 128 is on there, that means we have 128, isn't it? Plus, the next bit that is on is what? 64, isn't it? Plus what? Plus, next bit is what? 32. Plus, 16 is not on, it's off, so we cannot add 16. Are you following? Next bit that is on is what? 8, so we add 8. Plus, next one is what? 4, plus 4. Plus what? This 2 now, is 2 on or off? It's off, so we are not adding 2. 1, is it on or off? It's on, so we add 1. So, do the math, add this number. 237. So this number 237 is equivalent to 11101101 in what? Binary. Does it make sense? Alright, let's do it from the slide. See it. Let's do it from the slide that you're seeing. The board is not clear. Now we have a number 182. Can you see this number? Can you see the number 182? Now, in the table when they converted the number 182 to binary, 182, 1 is on for column 128, isn't it? 1 is also, okay, 1 is not on for 64, but 1 is on for, 1 is on for, 1 is not on for 8, isn't it? But 1 is on for 4 and for 2, and 1 is not on for column 1. So at the end of the day, if, for instance, now we don't know what this side is, do you follow? But we have the binary number already. Now what do we do to convert that binary number to the decimal number? It's by what? adding up the values of that column. So for the first column, we know that first column is equivalent to what? 128. And since it's on, we're going to write it down there. Can we see it? Are we seeing it? The next one that is on is what? Column 32, isn't it? Can we see 32 there? Did he add 64 there? We didn't add it because 64 is what? Off. The next one that is on is column 16. You can see it there on the board. 16. And 4 is on. 4 is on there. 2 is on. 2 is there. Is 1 on? Are you seeing 1 here? No. At the end of the day, add this number together. 128 plus 32 plus 16 plus 4 plus 2. You're going to get what? 182. So, even when you're writing your exams or while you are doing your conversion, you can check, proofread yourself. If you convert the number from 182 to binary, convert it back from binary to decimal. If you get what you started with, that means you are what? Correct. If you did not get what you started with, that means you are what? Incorrect. Are we following? Does it make sense? So I believe any one of us here in this class now can convert from decimal to binary. And we can also convert from binary to what? Decimal. Any question? Okay?
If the digits are more than 8, because these are 8 digits.
If the digits are more than 8, that's simple. If the digits are more than 8, the number is going to be greater than what? 255. Isn't it? Let's do it. We have 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Add it now, add it. What do you get? 2 what? Add it. Add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. 2 what? So that means the next number, 256, is going to have how many bits now? 9 bits. Do you understand? Do you understand? Yes. Because that number now will overflow to another column, isn't it? Yes. So that means we cannot have an 8-bit number that is greater than 255. Are you following? All right. Now, I have another scenario. What if you are given a number that is not up to 8 bits? For instance, I give you a number that looks like this. I give you a number that looks like 1111 base 2. And I say convert it to base 10. What will you do? Huh? What will you do? Okay? You're paying attention now. All right. Yes. I give you a number now, 4-bit number instead of 8-bit.
That's
4 ones.
1111.
Yeah.
So the first thing you do is 1 times 1 raised to power 3 plus 1 times the next number raised to power 2 plus 1 times. Then when you are done, add them, you have your base 10.
Okay, that's the mathematical way. We are not in mathematics class. Which class are we in? Cyber security, right? Disregard what the mathematics guy is telling you. It's not in this class. I said, we already know how to do it if the number was 8-bit, isn't it? If that number was 8-bit, you know what to do. Now, the simple thing to do is, you convert that 4-bit number, I give you a 4-bit number, you convert that 4-bit number to what? 8-bit. How do I convert it to 8-bit? It's by the addition of 0 before the number, isn't it? So Here we have 4 bits. To make it 8 bits, we have 4 zeros. Does that make sense? Can this number now, can we now plug it into that table? Do you understand? So that means for the first 4, which is 128, 64, 32, and 16, we're going to have zeros all around there, isn't it? Then the next one, which is 8, 4, 2, and 1, we're going to have what? 1s. And if you add that number, 8 plus 4 plus 2 plus 1 is what? 15. So you have gotten 15 in base what? 10. Did you follow? Okay? We're done with conversion. The next part of the class is what? Subnetting. We have done plenty things already. Who can tell me what we've done? If you know what we've done in this class, first of all. Okay? Tell me.
We've learned about IPv4
Okay.
and how they are in decimal format.
All right.
8 bits.
Number.
32 bits, sorry. I've learned about how to convert from decimal to binary and from binary to decimal.
All right.
We learned about IP addresses.
Any other person? What have you learned so far? What have you learned so far in this class?
Okay, I've learned about IP addresses and types of IP addresses, and also how to convert what IP addresses is used.
Okay. Close to break time. You want to go on break? All right. So the next topic is what? Subnet. And I already defined what subnet is, isn't it? What's subnet? Division of a big network into logical, smaller networks. Are we following? Let me turn it on. You have a question?
Yeah.
Huh?
Yes, for you. I don't know if it's my I think we're converting to binary. After converting, I don't think I'm just trying to get it. It is not sure everybody. The first one now was 199, the second was 198. Like just put 199, they put dots. That's after going to binary.
You should already know that there's a dot now. That's why I divided it.
So I mean the binary is
It's still a dot.
More dots. I don't think everybody knows about this because you did not see it.
Okay. So, can you see it here? All right. This is what your colleague is suggesting, that you should know. He's saying I should tell everyone in the class that whenever you convert your numbers from the decimal to the binary, you should not forget that there is a dot separating them, isn't it? So you should do what? Add a dot. Is that all? Yes, that's all. Will you tell him thank you? When you're done converting 199 and you get the 8-bit number, which is this. In this case, we are converting 182. The 8-bit number is this. After that 182, you put a word, a dot. Can you see the dot? Which line? After the first 8-bit number, you put a word, you convert the second octet, 92. When you get the binary number, you write it down and put a word, a dot. Are you there? You convert the third octet, 199. You put a word, a dot after the number. You convert 27. You put a word. Okay, 27 is the ending, so no need for a dot there. Do you follow? Alright, let's head over to the subnet now. Quiet. Quiet, please. We said subnetting is the act of dividing the network into logical subnets, isn't it? Now, whenever we do that, we must indicate that we have divided it, isn't it? You have an IP address, and you have divided that IP address into a small subnet. For instance, we have faculty of computing, isn't it? We have faculty of computing, isn't it? Now, the faculty has divided us into three, which is Department of Cybersecurity, Department of IT. Okay, it has passed. But anyways, when you were divided, all of you now have, all of us under cybersecurity. Do we have a uniform department name? No. We have now Department of Cybersecurity. Huh? Okay, in fact, cybersecurity, we are further divided again. That's what I'm saying. So, in Faculty of Computing, we have Department of Cybersecurity, isn't it? Faculty of Computing is the big network, which we have subdivided into 3 departments. Are we following? So now, everyone from their department will be having a uniform department name, isn't it? So all of us in cybersecurity now, if they ask you what's your department, you say it's what? Cybersecurity. In the network, when you do that, when you divide a big network into a logical subnet, you're going to identify that subnet with the name we call the subnet mask. Are we following? So the subnet mask is what identifies the subnet. Can you turn on this projector? Okay. The work of that subnet mask is to tell you where 2 things in an IP address occurs. Let me go again with our math number. If I look at your math number, from the first 4 characters, is it 4 characters? The first 4 characters tells me your year of admission. You 2023. Okay, first 5 characters. first 5 characters tells me your year of what? Admission, isn't it? The next letter is what? A slash, isn't it? A slash that divides the year out. What's the next character? It shows your department code, isn't it? So what's our department code? 5571. After that, the remaining 3 shows your what? Your identity code in the what? In the department. Okay? In the IP address, we just have 2. The first part is what we call group 1, please reduce your noise. The first part is what we call the network part. And the second part is what we call the what? The host part. Are we following? The subnet mask is what tells you where the network part stops and where the host part begins. Are we following? Are we following? The subnet mask, it's what divides the network into 2 parts. The network part and the what? The host part. Host. H-O-S-T. Host. Like from your mat number again, what do you think the network part is? Like your department, isn't it? Your department code. From you all the way to your department code is all about what? The network part. Why the host part is going to be what? Your identity code. So your computer, your smartphone in the network having an IP address, the remaining part is now what? The host part, which is the identity code of your device in that network. So that means if, for instance, all of us connected to the router that we used for exams, which has just one network, isn't it? One network. We all connected to that one network. That means all of us in the class are going to be having similar network address, isn't it? Isn't it? Why the host address will not be what? Unique. That's the work of the subnet mask. So if you know how to check it, which is what we're going to do in the practical, you'll see that your network card can be something like 192.168.1, right? While everyone in the network now, we're having something like 192.168.1.2, 192.168.1.3. Are we following? 192.168.1.4. What's common there? The network part, which is what? 192.168.1. What tells us where that network part stops when we look at an IP address, a single IP address, is the what? Is the subnet mask. Can you turn it on, please? Are we following? Okay. Give me. All right. So we've understand the function of, we've understood the function of the subnet mask, isn't it? Isn't it? The subnet mask is responsible for telling us where the network address stops, isn't it? And it also shows us where the host address begins. All right, so let's look at the next slide. An example, we have 199, quiet, group 1. You're making noise. I'm looking at you, you're making noise. We have 199.87.50, hold on, .5. Is that a valid IP address? Is that a valid IP address? All right. Now, we're saying this address is assigned to a device in the network, and the associated subnet mask is a value of 255.255.255.0. Can you see that? The 255 decimal number identifies what we call the network portion, and 0 represents the host portion. So all devices on this network will be having a number that is similar with 199.87.50. Do you understand? This is the subnet max number. This is the subnet max number. 255.255.255.0. Hold on. Are we there? Now, the last octet, is there any 255 there? Is there any 255 on the last octet? What that tells you is that in the network address, that is the IP address, only the last octet is allowed to change. Is it making sense now? The other side now, other sides that are fixed already with the value of 255.255.255. All those ones are fixed. They are not going to change. The only one that is allowed to change is 0. So that means everybody in that network is going to have their first 3 octet as 199.87.50. So the IP address can be ranged from .0, .2, .1, .2, all the way to .255. Does that make sense? So can you see the subnet mask in play now? Can we see it? In the subnet mask that tells us where the network portion stops and where the host portion begins. Does it make sense? All right. Now, it's break time, right? When are we going to come back? 1:30. We're going to come back by 12:30. 1 hour. Huh? Mama Abuja. All right. Please come back by 12:45 so that we'll start by 1. If I tell you to come back by 1, some of you will come back by 1:30. By 1, we are starting our practicals. So come back by 12:45 so that before 1, we are ready for the practicals.